Matrices and systems of linear equations, part 2. Okay, so we've been talking about using the matrix method to solve systems of equations. We've talked about row echelon form. Row echelon form is that diagonal of ones with the zeros below, row echelon form. Reduced row echelon form is not only having the diagonal of ones and the zeros below, but also as zeros above. If we have zeros below the diagonal and zeros above the diagonal, then it's called reduced row echelon form. Reduced row echelon form is going to be our preferred method. We're only going to do this one. If, for example, this were variables x, y, and z, and the other side of the equal sign, here we would say x is equal to 1. The official equation is x plus 0 is 1, so that's just x equals 1. 0x plus y plus 0z, the zeros cancel out the x and the z, leaving us with just y equals 2. 0x, 0y plus z, so that's just z equals 3, and we have the quickest answer with reduced row echelon form. Row echelon form requires us to do back substitution. We're just going to zip at the answers, R, R, E, F. Okay, the system of linear equations has a unique solution. Find the solution using Gaussian elimination. That's R, R, E, F. Oops, my bad. R, E, F. Gauss-Jordan elimination is R, R, E, F, and the preferred method. I don't want to do R, E, F and back substitute. I just want to get right at the answer, R, R, E, F. We start out by setting up our augmented matrix. We're going to write coefficients of our variables, x, y, and z, and then those numbers on the other side of the equal sign. Coefficients of x, y, and z become 1, 1, and 6. Other side of the equal sign is a 3. Coefficients of x, y, and z are 1, 1, 3. Other side of the equal sign is a 3. Coefficients 1, 2, and 4. 1, 2, and 4. The other side of the equal sign is a 7. And this is what's called our augmented matrix. We're going to go to our calculator. We're going to get those put in. We say second matrix, edit. It's asking us for the size of our matrix, and size is the rows first and then the column second. Rows go this way, so there are 3 rows. Columns go this way, 1, 2, 3, 4 columns. So our size for this matrix is a 3 by 4. So put in our 3, we'll put in our 4, and we're now ready for coefficients. 1, 1, 6, 3. Next equation, 1, 1, 3, 3. Third equation, 1, 2, 4, and 7. If I say second quit to get to our home screen, second matrix A, that just gives us a quick visual. Did I get everything put in the correct way? Looks like we're good there. So we're ready for second matrix math. And in second matrix math, we're going to use the up arrow to find the quickest way to RREF, Gauss-Jordan elimination. Okay, so we're going to RREF matrix A. Okay, so here's our variable x, our variable y, our variable z, and what we can see is in this first equation, x equals -1. That's the other side of the equal sign. So x equals -1. Then we see that y is equal to 4, and that's what we get from row 2. Y equals 4. Then row 3, we get z is equal to 0. Now, in solving our system of equations, we are looking for that order triple x, y, z, and we have our values found. X is -1, y is 4, and z is 0. And there's our solution, the quickest using RREF. Determine whether the system of linear equations is inconsistent. Inconsistent means that it has no solution. Or dependent. Dependent means when we are looking at graphing, they were the same equation, one on top of another. That would be dependent. If dependent, find the complete solution. Okay, so let's figure out what they want. We start out with our augmented matrix. We're going to write down coefficients of x, y, and z, other side of the equal sign. Okay, so variable missing, so that's got to be a 0. So we're going to say 1, 0, 3. Other side of the equal sign is a 3. Row 2, or equation 2, is 2, 1, -2. Other side of the equal sign, 5. Missing x, so we're going to throw a 0 in there. 0, -1, 8. And then other side of the equal sign is an 8. In this augmented matrix, we have 3 rows. Rows go left to right, and we have 4 columns. Columns go up and down. Columns go up and down. So we have a 3 by 4 augmented matrix. Okay, second matrix edit. We'll go ahead and put that in matrix A. Okay, so our size is the same as it was before, 3 by 4, and now we're ready for our entries. 1, 0, 3, 3. Second row, 2, 1, -2, 5, 0, -1, 8, and an 8. Okay, so we're going to do a second matrix after we get to the home page. Let me make sure I'm at the home page. Okay, we'll clear that stuff out. Okay, so second matrix A. That's our quick visual. Did we put in everything correctly? And that looks good to me. So now we're going to do a second matrix math up arrow to get to RREF faster. We're going to reduce row echelon form. We're going to use the Gauss-Jordan elimination method to solve matrix A. Okay, we hit enter. Okay, so here's what we got from RREF, and as usual, we look at our coefficients x, y, z, and then the other side of the equal sign. What this bottom row here says, 0 plus 0 plus 0, which is 0. 0 equals 1, the other side of the equal sign. We know 0 does not equal 1, so this is an example of no solution. Okay, so our last example for this section, let's set up our augmented matrix. So we're going to go ahead and write out coefficients for x, y, and z. We have 1, -2, 5. Other side of the equal sign, we see a 3. Row 2, or equation 2, -2, 6, -11, and 1. Equation, or row 3, is 3, 16, 20, and -26. There's our augmented matrix. We're going to get this augmented matrix put into our calculator. Second matrix edit. We have 3 rows, 4 columns. We put in our entries, 1, -2, 5, and 3. Next row, -2, 6, -11, and 1. Last row, we have 3, -16, 20, and -26. Okay, we can go back to our home screen. Second matrix A brings up what we just typed in. I'm just going to do a quick check, make sure I have everything entered correctly. Looks good. Second matrix, math, up arrow to get as quick as we can to RREF. We're going to RREF matrix A. Now in this case, notice that we have fractions, and those aren't hard fractions to figure out what they are, but in case they do turn out that way, notice that if we go into the math menu, option 1 is answer in fraction. So I'm just going to hit enter, and that changed everything to fractions. Okay, so we have our variables x, y, z. We have the other side of the equal sign. And if we look at this last row, what this last row means, 0 equals 0, which is a true statement, but we're not going to get a value for z out of that. So we're going to say that z is arbitrary. So in our order triple, z is just going to be some arbitrary number. Now we've got to fill in something for y and something from x. We come back and look at each of these equations. Okay, so this would be 0x plus y minus 1/2 z is equal to 7/2, or y equals 1/2 z plus 7/2. That's going to go into the y position of our order triple. 1/2 z plus 7/2. Okay, then for our last equation, this one here, we have x, 0y, wipes y out, so we have x plus 4z equals 10. So we have x equals -4z plus 10. And all we have to do is put that into the x position in our ordered triple. So we have -4z plus 10. And there's our infinite solutions.